Welcome to I Want to Make. In honor of Women's History Month, I wanted to invite my friend and fellow maker, Hunter Futo, to talk about her new product. Hunter is the founder of Electric Church, an electronics and digital fabrication lab for creative uses of emerging technology. Last year, she invented a reusable N95 respirator and formed a startup to get the device certified and manufactured. I met Hunter at a hackerspace in Pasadena and attended several of her workshops. Hunter, welcome to I Want to Make.
Thank you. Thank you for having me.
So I wanted you to tell us about your product. Does it have a name?
My product is called the Basic Respirator.
Cool. And what kind of problem is it solving?
So last year when there were shortages, I think it was around March, I needed a respirator to wear since I have asthma. I wanted to be able to protect myself. But then also I noticed that hospitals had shortages as well. So I started with 3D printing respirators and I figured out that they weren't very safe and there were some reports about them. So I set out to design something that didn't use all 3D printed components and was flexible. So I created this. This is actually made out of fabric, and it's going to be very similar if you've ever seen a 3D printed respirator online. It usually has a giant filter in the middle, so that functionally it's the same, but this has fabric, so it's bendy, and then it also fits to your face. So when you talk, the fabric flexes and moves. So I have a little inner gasket here that provides a little bit of thickness. And will stick to your face, and then I have a metal wire inside so you can shape it around your nose, and then straps that go in the back that you can adjust.
What was the most fun part of inventing this product?
At first, it took me maybe a couple of days to come up with a prototype. So I do a little bit of fashion design and pattern making. And normally what I do is draping. So I literally just took some Tyvek and I cut out a shape that fit my face. And then I cut out the center hole, and then I made I modeled the 3D printed filter enclosure to go inside of it. So that process was fun because it was just very rapid and I could test really quickly, and it was awesome to be able to come up with something so quickly that was functional. And Tyvek, the material that I was using, does happen to block bacteria, so over 95%. So I was able to be wearing a respirator within a couple of days. But then I entered a hackathon maybe about a month later, and I was paired with a first responder. And so I got a chance to interview someone that was out in the field, active around, patients with coronavirus, because they're first responders, so they're usually first on the scene. And I got to ask them about their problems. And I think that was, it's not fun because we're talking about how to save their lives, but it was fun in the sense that we could, I could help them solve a problem. And they had some problems with the respirators that they had because they were using disposables at that time.
Wow, very cool. And how many iterations of this prototype, or how many prototypes would you say you've made?
It's well over 100 probably. Again, because I work with paper, I'm able to prototype really, really quickly. So I started out in Illustrator, and I, created the outline, and then I can just print it right on my inkjet printer, and then test it, see if it works. And then to get the mask to fit exactly, I had to make little tiny adjustments. So that way, I had to incorporate, if you wear goggles or glasses, it needs to fit. So I needed to move it down a bit. I needed to adjust the volume inside the cavity because it needs to be under a certain volume for it to be safe, because when you exhale, there's CO2 that builds up in there. And then I also have 5 sizes that I need to account for. So I think overall, I have so many prototypes, but it was fast and it was easy to do. Working with my hands, I think, is fun because and that's one of the things that I like about making too. And because I was doing a lot of software programming before, but there's something about physically working with your hands and having a tangible object that you can test in a real life with physics involved. You don't really get that on the computer so much. On the computer, things tend to be perfect, and then of course you print it later on, and then things tend to fall apart. So I do like working with my hands. I like both versions, being able to switch back and forth, but there's definitely a benefit working with my hands.
How did you get into making and inventing?
It started when I was a kid. So my dad has a machine shop in our garage. So our first floor was just all machines. So like, sheet metal bending and, drilling and lathes and mills. And so I grew up in that environment. He was also constantly working on the house, and I was his, right hand. So I had to learn how to use power tools when I was maybe 6, I think, and hand him tools. So I had to learn all of that. So I think I became comfortable around that type of equipment, and then just learning how to build stuff. So he's an engineer, but he's very much a inventor maker type of engineer. So he likes to come up with problems to solve and then make them. So that's how I spent my childhood. And then I switched to I did fashion design school for a little bit, but it wasn't quite what I thought it was going to be. I think there was probably a bit more emphasis on style and less emphasis on making. So that's when I switched to hardware and making physical interfaces. So I'm kind of thinking of maybe like the next internet, I guess. I know there's Internet of Things, but I'm looking. I like being on the bleeding edge of technology. So that's why I'm in this space.
Do you remember the first thing you invented?
Yeah, so it was for the 4th grade science fair. I was 9, and I guess we must have learned about the environment, and because I was very concerned about the environment at that time. And one of the things my dad does for a living is refrigeration, so he builds these giant refrigeration systems. And he was telling me about propane, that was an environmentally friendly gas. So I thought that was interesting, and somehow we came up with this idea of making a refrigerator run on propane instead of Freon, because propane is much better for the ozone layer. So he came up with the design, obviously, because I'm 9. I don't, but he taught me every aspect of how a refrigerator works, and probably if I looked in the back of my fridge, I could tell you exactly what it was. So we took one apart, put it back together, but we rigged it to hook it up with propane and brought it into school, plugged it in, and it worked. And then he used it as his beer fridge in his garage for like 20 years after that. So it was a really good fridge. And then it wasn't until maybe a few years ago I was looking it up, and that was highly explosive, and that was really dangerous for me to bring into a grade school, because if I did anything wrong, I mean, I soldered everything myself, like the entire system. Wow. So if there was any leak and a spark, it would have blown up the school. So,
oh my God. But it didn't.
Yeah, I'm glad that didn't. It didn't. And it was, it was fun.
Wow. What would you say discourages women from getting into STEM fields?
There are a lot of things. I mean, I think I'm really fortunate in the environment that I grew up in, and especially with the dad that I had. He never treated me like a girl around tools and things. He had the same expectations for me as my brother, probably even higher expectations for me. So I was comfortable getting into that. But that said, once I was in an environment with other men, it's a little difficult being a female into a space that is dominated by men. It's also just kind of a different social environment too. So, I mean, again, I was used to that. I grew up around men, and like there's, it's always like the teasing and the banter and stuff. So I could roll with that. But there's sometimes a subtlety, that, you don't quite feel like you fit in. So I think that's one of the difficult aspects of it.
And do you have any advice for women getting into STEM that have the same obstacles?
I would suggest finding a group of women, or at least one other woman or non-binary person that shares the same passions that you do, and team up with them and have a support system. I mean, they don't even necessarily have to be engineers, really just anyone that makes anything. And have that support system in place, so that way when you are in those environments and you may have, you may get, some comments or harassed or something, you have that support network to fall back on. Other than that, it's really just about self-belief, which is hard because engineering is difficult. And I think anytime, especially, engineering tends to attract smart people. And so it tends to be whenever something is hard, I'm not necessarily used to that. So it makes me think, oh, I'm just stupid. I don't get this. And that's the inner voice that you have in your head. And I think women especially have that kind of imposter syndrome. So you have to learn to recognize that voice, and understand that just because something is difficult, it has nothing to do with your ability. It has to do with your learning and you're pushing yourself. And it's great when things are difficult because that means you're going to learn something new.
So back on your product, so what are you working on right now?
The design is pretty much done. So I have all of the basic functionality in place. Now it's just going to be a little bit of tweaks here and there to make sure that I'm meeting standards. I am getting it lab tested. One of the tests that I'll need to make sure of is that it is, in fact, 95% effective for microns, 0.3 microns. One of the issues that I've been seeing, and there's a lot of anecdotal evidence, is that disposable respirators don't always fit women. And some people of color, especially Asian women, they tend to be too big, and then a lot of times the nose piece doesn't fit. So fogging glasses is a problem. So I'm going to ask them some of those questions, and I'm going to do some measurement of their faces too. So I have an AR app component to this project where I'm able to scan and measure their face. And yeah, so it's just research and testing at this point. I'm fortunate that I'm being funded right now, so I have a little bit of grant money that's coming in that will just be able to pay for the testing. And then also I have some other vendors that are helping out because of the N95 respirator shortage.
Congrats, that's awesome. And you've had to learn as you go while you're working on this project, right?
When I started out, I had no idea how N95 respirators were designed. I have a reusable one that I use in my shop. I have a disposable one as well. But I really knew nothing about what I was taking on. I did have other designs online that I referenced, so I started there. Then I went to the NIH 3D print exchange, and they actually posted a lot of design advice through that site. Then I started reading scientific papers, and then I read through some of the NIOSH certification. And then I started consulting people, so calling people that work in regulatory and work for testing facilities, and so they helped me out with the design. The three major organizations that helped me, the first one is Just One Giant Lab. So it is an international open science lab. So they have a COVID-19 response. And I've been working with them since last March. It's primarily microbiologists and epidemiologists, but then also engineers. And everybody came together very quickly to address, the needs of the pandemic. That's a great organization of people that are working to solve a problem, and all volunteer based. So they do give us funding, but otherwise it's just people volunteering and coming together online. The other organization I wanted to call out is Challenge America and the VHA. So they were the ones that started the hackathon that I entered last May. And then when I won that, I was able to gain the support of the VHA and get a little bit of funding from them. So they also have a great pandemic response. They did a series of 5 challenges, and I think something like 40 projects came out of that. Again, all COVID-19 addressing the pandemic.
When you look at scientific studies or academic papers, how do you not get overwhelmed at just the lingo and everything that's in there? That's one thing that I struggle with.
I think that's a habit that I developed over time. So when I was in school, I took a class. I was in art school, but my science requirement was a neuroscience class, and it was like drugs in the human brain. I'm like, oh, that sounds cool. So she taught us how to read scientific papers. So ever since then, and I had a fascination with neuroscience, so I read it a lot. Honestly, it is overwhelming. But I look at the number of people that have cited that paper, and I look at all of the papers that they've cited, and I can generally, see if it's a reliable and trustworthy source. But yeah, for the most part, I glean what I want out of it, and then I move on. Oh, so for the cell pattern, so I'll give you a close-up look of it. This is actually pretty cool. This is a Voronoi tessellation. So yeah, I use a program called Rhino, which is a CAD program. A lot of environmental designers use it. And then Rhino has this amazing tool called Grasshopper, which is a node-based programming, I guess kind of a language almost. And you're able to do a lot of complex mathematics with it. So this is all math right here. So I created a circle, and then I created the cells inside. And so they're all randomly generated. It starts out where I have really, really, really tiny holes in the middle where your mouth is. And then I have larger holes around the outside. So I'm trying to even the airflow that's coming through and have as much airflow as I can, but not have too much in any one, no hot spots, I guess. So yeah, this was really fun to do. And again, 2 days it took me to come up with this. I have a magic 48-hour timeline of being able to come up with things. So I'd like to continue learning it because it's a lot of fun. I mean, it's just art. And I love nature and natural systems and the patterns that form from them. I don't know if this is necessarily appropriate because it looks like a sea creature that you're wearing on your face, but I use it because it's just so fun, and it also has a functional purpose too. So the design on here is interchangeable. I'll have to see what I'm able to do. But yeah, it's just such a beautiful process. So if you can download a trial of Rhino and Grasshopper and try it. It's a lot of fun to work with. So the respirator is patent pending, so I applied for a provisional patent. That was also something that I had to learn was about the patent process. So I'm very fortunate that I have a wonderful lawyer that likes to explain things in great technical detail. And he was able to evaluate my product and tell me, give me an indication of whether it is, whether it's likely to get a patent. So that's been a learning experience too. Another thing that I learned is that only 4%, I think over the last decade, only 4% of patents were awarded to women only. So that's a very, very small number. Also, the number of, I think in 2020, only 2.3% of women-led startups were funded by VCs. So when you look at the statistics of what I'm doing, I'm in a very, very, there's a small margin of error for me to try to meet.
Can you tell us about working with MLK Hospital and why you chose that hospital?
So last year, in working with hospitals, last March when the shortage happened, I started looking at hospitals in like the hospitals that I go to. So I have a doctor at USC. I have another doctor at UCLA. I had been to Cedars before. So I started calling those hospitals and asking if they needed supplies. And of course they did. And then I started thinking about some other hospitals in the area that may need supplies. And I started looking in South LA. And there were a couple of hospitals down there, one of them being Martin Luther King Jr. Hospital. And so I sent them some devices early on. And what I found is that, some of the hospitals in underserved areas, of course, were not getting all of the supplies that they needed. And they might have been getting even less than some of the bigger hospitals on the west side. So that's, one day when I was leaving Martin Luther King Jr. Hospital, there was this quote on the wall, and it was about injustice in the healthcare system. And I thought about that the entire way home, that it was an injustice that, they're already serving an underserved area. The people that work there are wonderful people. And so I thought, if I'm going to create a respirator, I want to make sure it's accessible to them. I don't want to create something fancy and super expensive. I want to create something that is accessible to every hospital, because those are the communities that are most vulnerable, and they need the spotlight on them. So that's one of my motivations for this project.
What was the most challenging aspect of this project?
So it can get really lonely and demotivating at times. Last year, I think during the protests too, I was just very affected by everything that was going on, and I quit. I was done. I was like, this is just not going to happen, and I stopped for a while. And then I don't want to get emotional, but I read about a woman that had died in Houston, and she was an OBGYN, and she was really young, like maybe 27. And she died because she had been reusing her N95 respirator over and over again. And I read that article, and she had such a beautiful smile, so that motivated me to get going again. And so during those low points, I try to think of, people like her, some of the Asian women that may have gotten sick because their mask doesn't fit them properly. Think about, doctors in underserved, and vulnerable communities that are working so hard, especially the nurses, as I think that's the majority of the people that are on the front lines. I try to think of them. We talk about healthcare heroes a lot and hashtag it. And I genuinely want to help them because I do see them as heroes that are fighting a war. So that's what I do when it just sucks, because oftentimes it does.
Yeah. Well, Hunter, this was amazing. Thank you so much for sharing this project with us.
Thank you. This was fun to have a conversation about, and it gave me some motivation to keep going. So thanks for having me.